Hello everyone, how's everybody doing? I hope you're doing fine. Hope coronavirus is keeping you at home so that you don't get sick or hurt. I mean by the police. So yeah, better stay at home, it's going to be compulsory pretty soon. It's going to be part of our daily lives maybe. Hopefully we all get back to our regular business. Not sure that's going to happen like regular. I don't know. There's going to be a lot of people unemployed. Who knows what's coming up? Riots, strikes, more violence, robberies, crime in general. Who knows? I guess it's going to be interesting the next few months. For those of you who are interested, I do have in the description a couple of articles that I published some years ago. I've been peddling for the last 20 years that we are the last generation of humans on Earth. Doesn't mean you're going to believe my theory. The purpose is to understand it, get a different perspective. You may not agree, fine. But it's good to get a different view that you won't see out there in mainstream. Okay, this channel in general has totally different views on just about everything, from the extinction of Neanderthal to the dinos to space-time and quantum mechanics and string theory, the whole works. Science is really in bad shape. And one of the reasons it's in bad shape, I'll tell you why. It's that for the last 400 years we have not been doing science. The 17th century so-called scientific revolution took us on the wrong path. It took us on the path of mathematics and took us on the path of doing experiments to develop technology. And people confuse those two disciplines or activities with what physics is supposed to, or science is supposed to be about, which is about explaining phenomena. You need to explain a mechanism. And what we don't have today is not one rational explanation, one rational mechanism, illustratable that you can illustrate there directly, right? For how, especially the invisible mechanisms of Mother Nature work, like gravity, magnetism, electricity, light, so on. So yeah, you can see the two articles. I got a couple articles and one informal article in the description there. I won't deal with that today. I'm going to deal with something else today. I'm going to deal with dimensions. Dimensions. What are dimensions? Well, it depends on who you ask, I guess. If you're going to ask a mathematician, you're going to get one answer. If you're going to ask a rational human being, you're going to get another. That's more or less how it goes. Okay, here's the main points that I want to make today. Okay, let's run through them real quickly. The dimensions of math have nothing to do with the dimensions of physics. Okay, math has some weird dimensions or notions of dimensions, and physics, rational physics at least, has very simple, very baby-like notions of dimensions. It's so hard, so difficult that it's just length, width, and height. That's it. We have length, width, and height. And math, now you need to take like 10 courses at the university to know what a dimension is, and you still come out without knowing. Okay, math dimensions have to do with measurement and magnitudes. Okay, and they don't have to do with what the dimensions of physics are, which are direction and orthogonality, perpendicularity. Okay, physical dimensions are strictly qualitative because of that. Okay, in math, anything is and can be a dimension. That's why they talk about infinite dimensions. Because you can, they have so many temperatures a dimension, mass is a dimension, shoes, where to buy shoes, that's a dimension. Everything's a dimension in mathematics. So that's why they talk about infinite dimensions. Hopefully, they're not implying that all these dimensions are nested, one inside the other, and that we live in nested universes. You know, three-dimensional here, four above it, five above that, and so on down the line. You know, that just means that you're trying to get rid of the question. You're saying you're not going to answer that question because, oh, we don't know. That's the answer there that infinite dimensions gives you. Okay? Math dimensions are actually number lines. And what these people have done is use the word dimension in the context of math for magnitudes. And they refer to them as, you know, dimensions or coordinates or vectors when they have nothing at all to do with dimensions, coordinates, or vectors, especially of those of physics. But it wouldn't matter anyways, because if they're going to make no distinction, like the next number on the list there, math, no distinction between dimension, coordinate, and vector. There is no distinction. In fact, dimensions are defined in terms of coordinates. What are coordinates? Just numbers. And so what these people are talking about, number lines, and I don't know why they call them dimensions, but they cross the line into physics when they try to give you a physical interpretation, and they tell you stuff like, space-time is four-dimensional. What do they mean like that? Are they extrapolating what we understand normally by three-dimensional to four dimensions? Is that what they're saying? That here we have a tree, a rock, or a house that is three-dimensional, right? And now we have some other thing unimaginable, unvisualizable out there that is four-dimensional. They're using that as they're extrapolating that notion of three-dimensional to four-dimensional when they say that. And so the question is, you know, is there something called four-dimensional out there? You know, an object. And when you find out that the fourth dimension is time, according to the mathematicians, right? Then yeah, you have a serious problem visualizing that object, because there is no such monster that is four-dimensional. Okay, it's just a lot of word wizardry. That's what it is. That's what it amounts to. Math invented the curved dimension. You know, you have length, width, and height, right, in physics. And they have two properties. They have direction. Each one of those has direction. And they have orthogonality. They have perpendicularity, one with respect to the other two. There is no such thing or notion as length without width and height. And vice versa. You can't have height without width and length and so on. Okay, you need those because it has two properties. One is direction and the other one is perpendicularity. And the question is whether you can bend direction. I mean, as far as I know, direction is always straight. You point straight, you know, wherever direction is. And these people are making curved dimensions. They're curving the dimensions around the spheres or whatever. Unbelievable. And, you had a couple of geniuses in the 19th century. One was Lobachevsky, a Russian guy, and another one was, what was his name? Riemann. And they curved the triangles. Again, they were using curved dimensions. A curved triangle. I don't know what that is. I have no idea what a curved triangle is. So, they modified the language a lot to accommodate all these notions, okay? And they ended up with irrational language, primarily three words. One of them is space. The word space is just outrageous, the notions they have in mathematics, okay? And as long as they keep them there in the asylum, no problem. The problem is they extrapolate there or try to bring those into physics, into science. And that's where we have a problem. As long as they keep it in the mental asylum, we have no problem. They can call it whatever they want, space. And so they talk about space and they equate it with solids many a time because that's one of the synonyms of space. Dimension itself, dimensional coordinates and vectors, completely irrational language that they have created In fact, we're going to go through a list of some of the notions or the concepts that they've developed for dimensions. And you're going to see that it's just mind-boggling. Not mind-boggling in the sense that, oh, I got to study this. No, in the sense that it should all be thrown away in the garbage can. We have no need for this nonsense, okay? And what all this shows in the end is that math is not the language of physics, okay? A lot of people tout it as saying, oh yeah, math is the language of physics. No, the language of physics is illustration. You have to be able to illustrate a mechanism so that people can watch the movie with all your illustrations there in motion and understand the mechanism. What mechanisms? Especially the invisible mechanisms. We want to see magnetism. We want to see gravity. We want to see how light works. We want to see how electricity works, how the atom works. All the invisible stuff. That's what they need to do. We know all the visible stuff, you know, but it's the invisible stuff that we have no rational explanations from the establishment, from the mathematical establishment today. Why? Because they say that math and not illustration is the language of physics. That's where we have the problem. That's where the problem originates. And unfortunately, it's these people who have taken over so-called science, physics. They run the journals, and from the journals, you know, you have all these blogs and people who more or less translate that scientific language, as they call it, for the masses, so that they can get a glimpse in general of what these guys are thinking or doing out there. You know, it's just and it's all the same group. In other words, what you have is people who have blogs and more informal magazines, and they take the published papers and they translate them. So if you want to go in there and you want to publish something, they won't let you unless you play by their rules. You know, you have to play with math. Okay, you have to introduce math equations. No pictures, please, because they don't give a damn at all about physical interpretations. That's why all their physical interpretations are irrational and will always be, because they don't care about them. And so, you know, people want to ask those types of questions. They want to know how the universe runs, and they'll never get an answer from a rational answer from a qualitative point of view. They're only going to get some math nonsense that they don't understand, and then the other fellow will say, well, you know, you should have studied math like I did, you know, and then you would understand. And that's the answer. That's it. That's the answer all the time. Okay, so what are the definitions of dimension? Well, here we have the definition for mathematics. Branch known as mathematics, a language. Is mathematics the language of physics, of science? Well, is Chinese or Greek the language of physics? I mean, language is a language, right? What's different between math, has these hieroglyphics there. What's different between that and Greek? Or, I don't know, Spanish. Okay? You tell me. Okay, property of space, extension in a given direction. That's what a dimension is, okay, according to the Wikipedia. A straight line has one dimension, a parallelogram has two dimensions, and a parallelepiped has three dimensions. There you see them, 1, 2, and 3. Well, I have a problem with the first one. That number 1, you know, that's a line. I'll make it a little big. Well, I can't make it bigger. I'll make it bigger for me, only not for you. But if you look at that line, you know, you can see it. And you can see it. It means that it's not one dimension. It's got two dimensions. It's got width and height. So I don't know if anyone can draw one-dimensional anything. There is no such monster, no such object that is one-dimensional. So that's why they call it an extension. So is an extension a geometric figure? Okay, because the other two are figures, no doubt about it. Because the number 2 is two-dimensional, the third one is three-dimensional. No problem there. The problem is the first one. You know, what is a line? Is a line a geometric figure, an object? If it's defined as one-dimensional, if it's defined as extension, you know, what are we talking about? What is that? Is that distance? Is that distance traveled? Displacement, maybe? What is that? And until you zero in on those key questions, on those key words that they use, these people are just giving you word wizardry. That's all they're doing. That's why they claim they can't define the point, line, or the plane. Okay? Generalization of this property to spaces with curvilinear extension. Spaces? Spaces have extension? I thought space was nothing. I thought space was vacuum. And this is the issue. The issue is they use these words space, they bring it in there, and they're talking about spaces, meaning geometric figures such as planes or categories of geometric figures such as planes and solids. They call them spaces. That's where we start getting a little nebulous with the jargon. Okay? As the surface of a sphere. So here they have a curved dimension again. I don't know how you can curve direction. But if you can figure it out, please let me know, okay? The generalization of this property to vector spaces and to Hilbert space, okay? The generalization of this property to fractals, which can have dimensions that are non-integer real numbers. Who cares? Who cares what, what do you mean dimensions that have real numbers? What's dimension have to do with real numbers? And again, anyone dealing with fractals usually is, a little cuckoo in the head. These people are fascinated by these patterns they see in nature. I don't know, the snowflake, maybe the, the stem of a plant. They look for these patterns and they're fascinated by them. They call them fractals. They study them to exhaustion. And all that's nonsense. We don't need fractals on planet Earth or anywhere. Fractals are useless for almost everything. There's nothing we can do with fractals. What's the point of fractals? Fractals is nonsense. That's what it is. And a lot of people are just absolutely fascinated by those patterns. They see, I guess, they see information there. Mother Nature's telling them something. Okay, and then last one, extension in time. Space-time has 3 dimensions of space and 1 of time. Okay, whatever space-time is, when you look it up, you always find that fishnet there. That's what you always find. Then they tell you not to take it seriously, not to take it literally. Well, I'm taking it literally because that's what's in front of me. That's why I take it literally. If you don't like that, bring me space-time. The real McCoy. I mean, that's what they always put. A 3-dimensional fishnet projected onto a 2-dimensional platform or background. And I'm not supposed to take that literally? What am I supposed to do? What am I supposed to interpret from this? Here they have the Earth sitting on space-time and on this fishnet. So ridiculous. So ridiculous. Okay. Okay. And here we have Mr. Stephen Hawking, and he died a couple years ago. And what did he say? Well, in his book he goes in there and he has this space-time diagram. But notice that he's got space as the coordinates or as the dimensions or as the vectors. Who knows what those are? Space. Never heard of a dimension called space. The issue is that he says, the mathematicians say that length, width, and height, well, that's not what they mean by dimensions. But then that's what they show. They show length, width, and height. They call length and width space. They call height time. Supposedly those 3 are 90 degrees to each other. So they're depicting dimensions of physics, okay? And that's what they want you to understand, that they're talking about physics because they're going to reach conclusions, physical interpretations, which they always say they've proven. Okay, they're going to shove it down your throat as proof. And what do they show? They show space and space, and in the elevation or height or who knows what that is there, they have time. Can you pit time against space? Does that make sense? Can you pit time against length and width? Does time flow at 90 degrees to length and width? And again, they put arrows, but length and width don't have arrows. Length and width are qualitative lines, parameters, or whatever you want to call them. They don't grow. And see, they put arrows like if they grow. Time grows. The arrow for time is okay, but for space, whatever space is, there's no dimension called space, but that's what he puts. So yeah, you got to look at all this in the proper context. What are they talking about? Are they talking about math? Or are they talking about length, width, and height, which belongs to physics? Because we can all understand length, width, and height. And that's three-dimensional. That's what we call it. A table is three-dimensional if it has length, width, and height. The one that's sitting here, it's a three-dimensional table. No problem there. But these people are talking about some abstraction out there, and then they hint or insinuate through their drawings that they're talking about the real world. And they're introducing length, width, and height, and they're calling it space and time. So what are we talking about? Are we talking about space and time, whatever that is, time running perpendicular to space? Is that what they're showing there? It makes no sense what these people are talking about, what they're illustrating, and what they later on say, well, don't take it literally. It's like, why did I attend this conference if I'm not supposed to take any of this for real? Okay, what are the dimensions of physics according to the wise men of our days? Okay, and again, this is from the Wikipedia. It says measurement in length, width, and thickness. Thickness? Thickness is a dimension. Again, a lot of it to do with that next word there, magnitude, size. Matter has dimension. Okay, topology, a magnitude that serves to define the location of an element within a given set of a point on a line, an object in space, or an event in space-time. Well, let's look at these. Here we have these. Okay, put them over here. Okay, there you have a point on a line, an object in space, okay, or in a space, and an event in space-time, which is that fishnet you see there, the curved fishnet. Three-dimensional fishnet projected onto two-dimension. Nothing there is four-dimensional at all. Okay, that's the space-time fishnet. You don't have to take my word for it. You can go on the internet, just put the word space-time, and you'll always find this ridiculous fishnet. That's what they show. What is that fishnet supposed to be? What gives shape to the fishnet? In other words, what's the white stuff in between the fishnet there that gives the fishnet some background? What is that white stuff? Is that thought? I mean, these people put whatever nonsense there, and you're supposed to look at that and say, well, don't take it literally. Okay, I won't. So does any of this have anything to do with physics? I mean, here we have point on a line. There are no such things as points and lines, zero-dimensional points and one-dimensional lines in the real world of physics. There's no such thing as that last one, space-time fishnet. They can't illustrate it because they cannot even imagine it. So if we cannot even imagine it, are they talking about the real world? Is the real world unimaginable? I mean, as far as I know, from here on out to the end of infinity, wherever the last bit of matter in the universe is, it's all 3D. From Earth outwards, it's all 3D. You can just run three coordinates or three dimensions if you want to look at the whole bit of matter, freeze the world, the universe, and just put dimensions there to measure all the matter in the universe. Well, you can only put three perpendicular lines. You can't put a fourth perpendicular line to those three. It's just that simple. And that tells you that everything from here on out is three-dimensional, using that notion of dimensions. Where is this fourth dimension, fifth dimension, or like in string theory, you got 10 and 26 dimensions? just absolute nonsense that has nothing to do with reality. Okay, and then they fix it by saying, well, there are tiny dimensions that are curly-cued around, hidden from our view. These people are deranged in their head, Okay, another notion is the number of elements in a finite basis of a given vector space. What is a vector space? Okay, let's see. Well, here we have a number of elements. Well, how many elements do we have there? Well, we have a couple Indians. We have bows, arrows. I don't know, maybe 10 elements. I mean, what does this have to do with physics? What they're saying here is that you can add two magnitudes. Those arrows represent magnitudes. You can add V plus W and get a third arrow. What is that third arrow? Is that an engine arrow? Is that one of those darts that some of these natives throw at you? No. Those arrows are just numbers, magnitudes. That's what they're showing you. And so, they depict them with arrows, and one thinks they're talking about arrows, but they're not. They're talking about numbers, which somehow they're trying to depict so that you can get a visualization of what they're more or less talking about. So, yeah, lots of problem with all that. And then there was, let's see this one here. Then you have this one, the last one there. What was it? For physics, any of a set of basic kinds of quantity as mass, length, and time. Is that what a dimension is? Mass, length, and time are dimensions? Well, let's find out. Let's see. Here I try to illustrate. Here's mass, length, and time. Okay, does mass run perpendicular to time or length? Does time run perpendicular to length and mass? I mean, what are these dimensions that they talk about? They use the word dimension every 2 seconds, especially in relativity. And this is what they're talking about. They're talking about nonsense that, doesn't fit our notions of what three-dimensionality means, or what length, width, and height means. So if that's not what a dimension means in mathematics, what does it mean? Well, what do you mean when you say mass is a dimension? What do you mean that when you say time is a dimension? How is time in any way similar to length? Are we talking about distance traveled? Are we talking about a length of a table? Or are we talking about three mutually perpendicular directions known as length, width, and height, which are qualitative, 100% qualitative? So the issue is that these people have lost track of what they're talking about, especially as long as they keep it in math, no problem. The problem is when they bring it into physics and try to tell you, we did all the mathematics here, we got all the equations, we got all the numbers, we got all the measurements and quantities, the amounts, the magnitudes, and now they're going to extrapolate that and try to give you a physical interpretation for how this universe works. Can they tell you how a magnet attracts another? No, they can't tell you that. But what they can tell you is what gravity is. It's warpage of time. That's what it is. They're warping space and time, both. Space-time. They warp space-time, that means they're warping time. Because they turn time into a stick. And now they can bend it or warp it or, who knows what. That's what they're doing. And, of course, after that they say, well, you're not supposed to take the analogy literally. Of course you, because I can't even imagine warping time. How am I supposed to even take it literally? There's nothing literal about it. It's all absolute nonsense to say that gravity is the warpage of time. If that's a mathematical description, they can keep it within math. Don't bring any of that into physics. Don't tell me that in physics, in science, in the rational world, that you're going to warp time. Okay, this is when it gets dangerous, when they say, well, time is a dimension, we're going to bend that dimension, we're going to curve it, which is what, the first few pictures there that I put show, okay? Okay, what's the formal definition of dimension? Because really they have a single, math and phys for them is the same thing. And so they have these, they try to give you an idea that there's a little difference between physics and math. No. Physics and math use this notion of dimension in both, math phys, by the way, okay? They use this notion of dimension in their so-called disciplines, okay? In physics and mathematics, the dimension of a mathematical space, what is it? The minimum number of coordinates needed to specify any point within it. Okay? So what are we saying? We're saying that a dimension is a coordinate. What is a coordinate? Well, we can see, when you look up the word coordinate, you won't find a definition. What you'll find is coordinate system. But it's okay, we go to coordinate system and it gives you an idea what a coordinate is. Okay, so what is it? A coordinate system is a system, okay, that uses one or more numbers or coordinates. So what is a coordinate? Another number. So what is the dimension? Well, a minimum number of coordinates, meaning a minimum number of numbers. That's the definition of a dimension in mathematics and math phys. Okay, it's the minimum number of numbers. Number of numbers. That's the definition they have today. Is that what three-dimensional means? That you got three numbers? You know, maybe you should play them at the lottery or something. You know, I mean, what does this have to do with science? What does this have to do with physics? With anything? Okay. And what are they used for? To uniquely determine the position of the points or other geometric elements on a manifold such as a Euclidean space. We're going to put points on spaces, on vacuum, on nothing. Okay, fine. But the interesting thing is the position of a point. And a point, what is a point? Well, it's a position. It's a location. That's what the word point means. So we got the position of a position, and the dimension is a number of numbers. You figure it out. You see if you can use any of that for anything, okay? Of course, none of this makes any sense. You will not be able to make sense from a true geometric, in other words, physical point of point of view, okay? If they want to keep all that nonsense in math, keep it there. Please don't bring it into physics. But it's when they try to bring it into physics, that's when we run into trouble. Because we cannot use these deranged, irrational, ridiculous notions that they've developed in mathematics. We cannot use them in physics for anything. Nothing at all. It's all total trash. Okay? So that's the issue. The issue is when they try to bring it over. If they want to use it in math to do their asylum stuff, go ahead and use it. I don't care. But don't bring it into physics. Okay, so let's see what we have. Here we have space, because we need a definition of space. They use this word space every 2 seconds. What is space? Well, they say space, again, this is from the wiki. Space is the boundless, three-dimensional extent. Space is an extent, whatever that is. Is that a physical object? I mean, it says three-dimensional. Why would they use the adjective three-dimensional to qualify extent? Are they saying this thingy, whatever they're talking about, this space, is growing or extending or pointing or facing in three mutually perpendicular directions? Is that what the three-dimensional adjective there means? Is that what it stands for? Three-dimensional extent. Okay? But then we have another word, the boundless. Are they saying space is infinite? It's a physical object that is infinite in extent. It extends forever. Keep that in mind, okay? In which objects and events have relative position and direction. Okay, at least they got one, direction. Okay, yeah, direction is part of it, but they forgot orthogonality. They never mentioned that. The fact that length, width, and height are 90 degrees to each other. They draw them that way, or at least they project them that way on two dimensions, implying that they're all at 90 degrees to each other, but then they never use that. They say, oh, but that's not what we mean by dimensions anyway. Dimensions are important stuff like mass and time and temperature. Yeah, I don't know if temperature runs at 90 degrees to time, you know. Physical space. Oh, there's a physical space, okay, is often conceived in three linear dimensions. It is? By whom? By the loonies at the asylum? I mean, what do you mean, physical space, three linear dimensions? What is this? What are they talking about? every word is irrational in this context. With time, to be part of a boundless, again, boundless, whatever that means, four-dimensional continuum. It's a continuum. Continuum, what could that mean? That there's no accidents, no interruptions? Is that what space-time is? Known as space-time. A continuum? What is a continuum? Is that a physical? Can you bring a continuum to the conference so we can see it, put it in the middle of the room so that we know what a continuum is? So all they have is all these concepts, extents and continuums. That's what they're talking about. That's what space and space-time are. The concept of space is considered to be blah, 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 of importance to an understanding of the physical universe. The concept of space? I mean, these are the questions. Is space an object or a concept? Does space have shape or not? It's a black or white issue. Is space a physical object? If it is, if it's got dimensions, as they say, it's three-dimensional, please bring a space to the conference next time. I want you to put it in the middle of the room so that we can all see it from all sides, all around. I want to see your three-dimensional space. What the hell are they talking about? What do you mean a three-dimensional space? No, space is what's out there between the Earth and the moon. That's called space. It's known as vacuum. It's nothing. That's what it is. Nothing. Nothing, that which has no shape. Something, that which has shape. Nothing, that which has no shape. There are antonyms. Now we can use these words consistently, rationally, scientifically. But to say that, space is three-dimensional, well, just bring it to the conference room. We'll find out if it is. Just prove it. They like to prove everything. Prove that space is three-dimensional. I want you to bring a bit of it, illustrate it. And then we'll know it's three-dimensional. If someone says, is your table three-dimensional? Say, yeah. And can you prove it? Yeah. And you bring the table in. You say, see, it's three dimensions. It's got length, width, and height, 90 degrees to each other. You're done. You proved it by bringing your table. Okay, do the same thing with space. Bring space in, show me that it's three-dimensional. It's got length, width, and height, because that's what three-dimensional means. Okay? Okay, so what was this other word? Bound, that it's non-bounded, or it's unbounded, okay? Unbounded. It's the unbounded space. What do they mean by that? Well, here, fortunately, we have Stephen Hawking, and he's going to tell us what no bounds means, no, unbounded. And the problem here is he's got two notions. One has to do with time, and then in another part of his book, he talks about something totally different, which is incessant walking. Okay? He says in the first one, space-time was finite, but had no boundary. Finite, no boundary. Here's a ball, it's finite in the sense that, it ends here, right? It's a discrete object, and then it's bounded. So what does he mean? How can it have be finite but no boundary? This has boundary and finite, both. How can you have, there seems to be a contradiction somewhere. How can you have something that is finite and not have a boundary? And he says it had no beginning, no moment of creation. Which is, I don't know, what does that have to do with finiteness and boundaryness? Okay. And then the next one, he says the universe is not infinite in space, but neither does space have any boundary. Okay. No boundary for space. And what is he talking about? Gravity is so strong that space is bent around unto itself. These guys are bending nothing. I mean, before you bend space, please bring it to the conference room so we know what you're talking about. What is this three-dimensional space that you're talking about that gravity bends it around itself? What are they talking about? What is this nonsense? What is this jargon, this language that they develop? Making it rather like the surface of the earth. Okay, two-dimensional, right? I guess the surface, that's what they say it is. And if one keeps traveling, now he's talking about traveling, trying to prove that it's infinite or unbounded, right? In a certain direction on the surface of the earth, one never comes up against an impassable barrier or falls over the edge, but eventually comes back to where one started. So how does that relate to the first one? The first one he says had no beginning. The second one, he's got a different notion of what he means by unbounded, which is, that you can walk around the earth incessantly. Here we have one fellow, he's walking around the earth, or around the ball at least, and he's walking incessantly. Okay, is that what unbounded means? I mean, that ball there, or that earth, whatever that is, that's bounded. It's finite. It ends at that surface. But walking incessantly is not unbounded. He's not walking unboundedly. He's walking incessantly. Stephen Hawking should learn language before he can say some of these things that he says, or that he said. Okay, here we have another mention from Stephen Hawking regarding dimensions. Again, these people are demented. I think they suffer from dementia. That's what dimension probably means in mathematics. The fourth dimension, time. Time is a dimension. Thought it was a number line. Is finite in extent. Okay, but it is like a line with two ends or boundaries. Okay, so we got a line, it's got an end. Okay, fine. A beginning and an end. We shall see later that when one combines general relativity with the uncertainty principle of quantum mechanics, it is possible for both space and time to be finite without any edges or boundaries. Because again, they're talking about stuff that has nothing to do with the word boundary. Because anything that is finite by definition has boundary. What they're talking about is not boundary, but saying that you can run around in circles, come back to your starting point, you won't find a wall. That's what they're saying. That's got nothing to do with boundary. So the way they show their unbounded universe, finite but unbounded universe, is with word wizardry. What they're doing is confusing concepts here. They're confusing the words, what they mean. The word unbounded has nothing to do with walking around. Okay, unbounded means the same thing as finite. If they want to use the correct word, they should say the universe is finite and you can walk around it incessantly. That's totally different. It's got nothing to do with whether the universe has edges, boundaries, a fence. Okay, let's keep the context in the right place. Okay, that's the problem. And he says more nonsense. The idea that one could go right around the universe and end up where one started makes good science fiction, but it doesn't have much practical significance because it can be shown that the universe would recollapse to zero size before one could get round. I don't even want to wait for his proof. I mean, total, absolute garbage, nonsense. These guys are paid big bucks to say this idiocy. They are. It's unbelievable. These guys, he died, but there's a whole bunch of others behind him that say the same nonsense. They get a lot of money for saying this idiocy. So yeah, I don't know. You should take it with a pinch of salt, okay? But what's interesting is after they do all their fancy footwork, here you have a couple of them. One is Stephen Hawking, and the other one is Leo Susskind. He's a professor at Stanford University. And what do these people say? Well, they say they can't imagine their own contraption, their own space-time. And here you have first one from Stephen Hawking. He says, it is often helpful to think of the four coordinates of an event as specifying its position in a four-dimensional space called space-time. Okay? It is impossible to imagine a four-dimensional space. So if it's impossible to imagine, maybe there's no such thing. Maybe that's why. And what they do is they go through this rigmarole, which you'll see next here, where they try to show you why we can't imagine it. It says, I can't say, now close your eyes and view in your head 5 dimensions, because I can't do it either. Okay, at least he concedes that. All I can do is say, take X, Y, and Z, and add V and W. Eventually, a person with this type of mathematical background begins to develop mathematical intuitions for things. In other words, you get brainwashed, okay? You start accepting stuff that is unimaginable, like spirits and heaven and hell, okay? Mathematics, they don't need the same kind of visualization, so we're stuck needing mathematics because evolution He blames it on evolution. Didn't equip us to visualize 11-dimensional space-times. So the fault is of the monkeys who gave birth to Leo Susskind. You know, all these forefathers that we had, they didn't give us the right tools. We're still stuck in 3 dimensions, and these guys are already at the 11th dimension. I mean, what does 11th dimension have to do with reality? This is all garbage, nonsense, poppycock that is being taught at the university level. These people should be executed for saying such nonsense. It's garbage. It's ridiculous. It's not even funny. Anyways, the other day I showed, and here I'll reinforce it. This is the difference between the definitions of math and the definitions of physics. In physics, the dimensions are straightforward, length, width, and height. Everybody can understand. It's just 3 mutually perpendicular directions. That's essentially what it is. What are coordinates? Well, the first point is that unlike dimensions that point outwards, dimensions point inwards towards an object. You need 3 sticks that are 90 degrees to each other to locate an object in the universe. You know, these are the only 3 possible mutually perpendicular directions. You cannot imagine a 4th direction. Okay, and they point towards the object always. Vectors, that has to do with motion, not with location or orientation. Vectors are motion. 3 mutually perpendicular directions in which an object can move. That's what vectors are. Okay? And it's depth, breadth, and elevation. Sometimes you'll find that these people confuse length with breadth, and they put latitude in there. They mix them all up because to them they're all what? Number lines, what you see on the bottom. That's what these so-called dimensions, coordinates, and vectors really are as far as mathematics is concerned. They are number lines, and these people call these number lines, you know, dimensions, coordinates, vectors. They use these terms which have nothing to do with what they're doing. They should call them all number lines. But see, if they call them number lines, then they can't say that space-time is 4 number lined. You wouldn't understand that. You would say, well, what do you mean it's 4 number lined? No, it's 4 dimensional. Oh, I understand that. It's 4D. I just can't imagine. It's like 3D, but 4D, right? No, it's 4 number lined. They're talking about 4 number lines that can converge upon an object to establish the locations with magnitudes, with numbers. That's all they're talking about. And that's totally different than what we say when we say that something is 3-dimensional. But they use the adjective 4-dimensional to modify or qualify space-time. So they treat space-time first as a physical object, even though it's got the word time in there, because they're going to do their gravity, their geometric gravity, by bending space-time. So they have to turn it into a physical object. And then they say, well, you cannot imagine it, but you need 4 dimensions, one of which is time, to locate a point within space-time. So it's a circular argument. You need, what is space-time? Space-time is what you need 4 dimensions to locate a point within space-time. That's what space-time is. So it's, and again, if they keep it within the asylum, the mathematical asylum, no problem. They can, all the patients there can do whatever they want with that. And hopefully someone throws in some coronavirus in there and just gets rid of all of them. But don't bring it into physics. Don't bring anything, the coronavirus or the dimensions of math into physics. They have no place in physics. In physics, it's length, width, and height. Kindergarten stuff. We're done. That's it. That's all we need dimensions for. Okay? And they're all qualitative. We have no necessity, no need for magnitudes. Okay? Because you cannot explain anything by putting magnitudes. You're going to explain a mechanism. You're not going to describe mathematically. That's why math is not the language of physics. Okay, there was another issue, and that's this issue of curves. What is a curve? Well, it turns out that, you know, the curve, some curves are straight. Unbelievable. And that's how they ended up with curved dimensions, because I guess, you know, it doesn't matter to them. Well, here are a couple definitions. Curve, an object similar to a line, okay, which does not have to be straight. meaning that sometimes it can be straight. Is that what they're insinuating here? Sometimes dimensions can be straight, sometimes they can be curved. And that's what a curve is, a curved direction, I guess. Okay. A curve is the image of a continuous function from an interval to a topological space. Okay. And then dictionary.com says a continuously bending line without angles. That more or less is the notion we have in physics. Continuously bending line, that's what a curve is. We never confuse a curve with a straight line, but these people say, well, a curve can also be straight. Because to them, it's a function. It's a function, it's an equation, it's a bunch of variables and numbers. That's what it means to them. It has nothing to do with what a curve is, what a rational human being understands for the word curve. If you ask anyone, did the car curve? Yeah, he went in a curve. That's why we call it a curve, because it bends, it warps. And if you see a straight line, you don't say that's a curve. No, you say it's a straight line. Nobody confuses a straight line with a curve except mathematicians. And again, they can keep that nonsense within mathematics, just don't bring it into physics, into the real world. Mathematics, also dictionary.com, a collection of points whose coordinates are continuous functions, again, of a single independent variable. Yeah, they're talking about function. They're talking about nonsense that has nothing to do with the word curve. Okay, and again, if they keep it in math, fine, just keep it there. Don't bring it here. There are no fewer than three, I like this comes from Wolfram Math World, and what you see there says there are no fewer than three distinct notions of curve throughout mathematics. So you can see that they have all these definitions. One guy uses one definition, the other guy uses another, and so we don't know what a curve is because everybody's got his own notion. It's all ad hoc. When they need it for this, they say, well, here I'm going to say that a curve is this. And the other guy said, no, well, for me, a curve is this other thing. And everybody's doing their own little thing there. And here you have, there's one for topology, the other one is for algebraic geometry, and the other one for analytic geometry. So they have all these notions of what a curve is, not even worth reading. Okay? In other words, no one knows in mathematics what a curve is. You got to take them to kindergarten to show what a curve is. You draw a little curved line and say, that's a curve. See how simple it was all these years? And why is this a problem? Well, here you have one bozo. His name was Arthur Eddington, and this guy supposedly proved that light curves around the sun, thus verifying, confirming, proving Einstein's notion of theory of general relativity of 1915, 1916. And he said, it's true. Look, see, we proved it. We went out there and we saw that we could see light coming around the sun, okay, during an eclipse. And there you have the notion. You see there's a star far away, and light goes around the sun, supposedly because the sun weighs down this canvas known as space-time, which you're not supposed to take literally, right? And it bends it, and it curves light. So they said, look, space-time bent light. You'll hear this constantly. They use that word, bent. And one of the problems there is that, no, we're not talking about bending, because if we're talking about a photon, a little ball, okay, we're talking about a little ball, a discrete little ball that's coming, right? Or even a little wave, because they say that a photon is really a wave, okay? So are these waves discrete? What are they? What is a photon? Isn't a photon treated as a discrete entity, a little ball? And if it's a little ball, then you cannot talk about bending light, about bending a photon. No, you can say that it swerved, you can say that it deflected. That would be the word that you would use. You would not say you bent a ball, you say that the ball was deflected. And these people are talking about bent light, as if there's a continuity in light from the star all the way to the earth, and you're bending it, you're warping light. Why? Because the weight of gravity is so heavy. Gravity pulls on light so much that it bends light. What is it bending? A beam? A ray? Is that what we're bending? So again, they have all these retarded notions that because they have contradictions. They have developed all these retarded, ridiculous notion of what space is, what curve means, what bent means, what a dimension is, what a coordinate is. They have all these incredible notions, this language that they developed. And unless, you really took a course in the university, you can't follow these guys because you don't really know what they're talking about in physical terms. But they claim to be talking in physical terms. They claim to be interpreting the real world out there, the priests of the modern world, as I call the mathematicians. These people are telling you, look, we can tell you how this universe works, but in order for you to understand us, you got to take a course, high-level course at the university. And so they can't bring it down to you because, they cannot illustrate it on the board. They say, look, here's the equation. Here are the numbers. And the only way you're going to understand it is if you take a course. And when you take the course, you still won't understand because you can't explain it in normal terms. You can only talk it to another mathematician, and they say, well, yeah, I understand what you're saying. And what are they doing? Descriptions. All they're doing is descriptions. That's all that math can do. Well, anyways, Arthur Eddington didn't prove squat, okay? And here it is. You'll find in the Wikipedia, you'll find tests of general relativity. Supposedly all these tests have proven general relativity. It's the evidence for the theory, okay? Observational evidence for the theory. And you'll see several of them there. No, let there be no doubt. No one proves anything in science, in physics, okay? No one proves anything in there. Proof means that they convinced you. You drank the Kool-Aid. That's what proof means. There is no such thing as proof in science. Proof belongs strictly to religion. It means you were convinced, and no one's going to convince you otherwise, that such and such is true. Because they proved it to you. You convinced yourself that it's true. Proof is not part of science. Science we don't prove. In science we explain a mechanism objectively so that you understand it. Then everybody goes his own ways and reaches his own conclusions. That's the way it's done in science. When someone talks about evidence and proof that they observed and now they can prove and now that they verified, they're talking religion. And especially when, they can't put it in normal terms. If they're not going to use the words consistently because they have 10, 20, 30, 100 definitions for each word. They have all kinds of dimensions. We don't know what a dimension is, and they say it's just a bunch of numbers. Well, if it's a bunch of numbers, why did you call it a dimension? Call it a number. Call it a magnitude, call it an amount, quantity, whatever you want to call it. But don't call it a dimension. Dimension is very clear what it is, length within height, because that's what the notion of three-dimensionality. So it's the language that's been contorted, and the big problem, again, is when they extrapolate that language into physics. Okay, with that, we'll see you next time around. We're going to continue on geometry. I want to make sure we cover just about every base we can with geometry before we let go. So we'll see you then, and take care. Bye-bye.